Thank you, Scott. Good morning, everyone. My name is Harish. I'm a staff software SRE engineer at Intuit Career Karma. Firstly, thank you, Stokelook team, for having me here to talk about something that I'm very passionate about and working very closely nowadays, like building and managing this enterprise MCP system. So when we comes to a point like building and deploying this MCP infra in secure and compliant environment, there are two things comes in mind, like shall we build our own MCP connector and gateway to connect the coding assistant tool to the MCP server, or we rely on some third-party software to build that bridge. We'll discuss today that what pattern we have been adopted and how we deploy MCP overall in general, and some best practices and recommendations. All right, let's begin. So first we'll talk about challenge and what challenge we had before, how we address those challenges through building some core component to it, how we deployed overall MCP through CI/CD, and how we expedite overall deployment cycle through some self-serve models. We'll also talk about some connector and gateway, which enabling the overall communication system. And then last but not least, the security monitoring and compliance, which is very, very essential when building such MCP ecosystem. All right, challenge. I know there are numerous challenges when we build this MCP. One of the key problem that we had is how we can let our developers to connect our backend MCP server in secure and in very isolated environment where there's no outbound internet is allowed. And if you look at we are also trying to connect some of this large data source system. Look at the scale and diversity of the system. I only highlighted few, by the way, here. But overall, if you look at the scale and diversity of this, connecting this all MCP is become like a non-trivial problem for us, especially when you get very stiff security requirement to access these systems. So to solve this problem, we built some core component to it. And since we are still in early stage of building this MCP, so we decided to build our own MCP connector and gateway to connect all our coding assistant tooling and agent to our backend MCP servers. Now, and we also ensure that when we're building this component, we leverage all our existing IAM policies and IDP framework to make sure that the whole system is secure and compliant enough. And now I'll talk about what is my first component that we have been built, so which is like MCP connector. So MCP connector is a lightweight TypeScript framework that we have been built and ship it to our registry. All user has to do is just download that connector locally by running that npx install command, and they will be able to connect to our MCP server through our secure gateway. Now, what is gateway? Again, this is where all the magic of orchestration happens. The moment you submit your prompt query, the tool request, the gateway is the one who help in authenticating that tool and then redirect you to the right backend MCP server. Now, the MCP server, again, we use the fast MCP framework that is provided by officially that MCP SDK environment. The way we built is we use our own customized base images, and every single package within the Docker file when building these images are coming from our Artifactory registry. Just to ensure, before we build this MCP, we do it in CI/CD pipeline in a secure environment to make sure that we ship it to the production with almost no vulnerability. Now, we'll talk about this component detail in a couple of slides later, but first we'll discuss that how we automated this whole MCP deployment cycle through CI/CD pipeline. So this slide will divide on the three areas. First, let developers to build their MCP server and scan the image and getting it ready for GKE deployment. The next section is about how this image is getting deployed in GKE, and the third part is how the end users are connecting to those MCP server via our gateway. So let's start. So you can see there are two developers. They are coming from two different teams, but the flow will look same for them. And I will start with just one here. So this developer, trying to create a MCP server repository. So we have a web framework, which I'm going to talk in the next slide. So this web framework is help users to create that GitHub repository automatically for their MCP with all the required framework. Now, once the repo is there, user can clone that repository, customize it, and then test that MCP server through MCP inspector, make sure that tools are responding fine, and then they will review and approve the PR with the team, and then finally the Circle CI will kicks in. The Circle CI will pick up those changes from PR automatically. It build that image in secure environment and put that in the registry. So once your image is there in the registry, then we have another workflow which actually scan the images. Generally, we let our security team to do it. They scan that image and they find any vulnerability, they send it back to us, we'll fix it, and then we resubmit the request. Finally, once the image gets scanned, it moves to the production registry. So once the image is there in the production registry, the next flow will kick in, where actually users are getting ready to deploy that image into the GK cluster. Again, we are trying to avoid any manual PR creations. Again, we have a web framework which you submit all the details about images. It will create automatic PR for you. All right, next, deployment into the GKE. Once your PR is getting merged, we have a Circle CI config which actually triggers the Flux framework like workflows, which will take care of deploying that MCP in their respective namespaces. Again, to avoid further complexity, I have not added any Armor or Ingress or services component here. Now, last part is like how users are connecting to it. So once the users are, have the MCP connector downloaded on their local, they can embed that MCP settings into their coding assistant tool, Cloud or Cursor, and they can access this MCP server via gateway. Right, so I think this process is overall pretty much auto deployment. The only human intervention is required when actually you customizing that MCP server repository to build your MCP server. And second is getting your PR reviews and submit for image scanning. The rest is like almost like is automated deployment process for us. Now I'm going to talk about in next slide that what this web framework is. So I know that many industry has their own web framework. We also have our own React-based web framework, which we built for our developer community to, build their workflows, monitor it, document it, and use for other engineering resources. We use similar web framework here as well to manage some of the MCP component. The first is like automating this MCP server framework. So there is a web portal where we can let users to ingest some of the information. For example, hey, this is my GitHub repository. This is my image. These are the tool I want. And this is the language like TypeScript, Go, Python, whatever it is, right? So you can submit those, and it will create a repository with that base framework for you. Imagine how much time you will save. And it will also maintain that standard across the team. So once you have that repository, you can customize it. You can build that Docker image locally, test it out, whatever STDIO if you're doing locally or HTTP for remote-based server. And then once you get the response, you are ready to scan that image. So next workflow is about very simple workflow. Just submit your image tag. And this workflow actually going to, Circle CI will kick in, and it will scan that image and create a vulnerability reports for you. The third cycle, again, third web portal is about creating a GitHub PR. Again, once your images are ready, you can ingest that, image into the workflow. It will create a GitHub PR for the GK deployment, which is get ready for the Flux deployment onwards. Now, again, this workflow is also taking care of enabling that MCP into the gateway. And the reason to showing all of this, it's just reduced overall your development time and reduce the friction and improve the overall efficiency for the team. So it's highly recommended, reduce all those manual PR creations and make that standard across the team. Now, last but not least, the server registry. So we have our own server registry. I'm sure many industries maintain their own workspaces or workplace service where they maintain lists of the MCP servers. So we have two registry. One is we show what our MCPs are in development right now, what are in production. So based on that, if somebody wants to try that out in local, they can just leverage this registry and download it. And this registry has enough information saying that, hey, this is my image, this is my repository, this is my GitHub tools and descriptions, so that your developers can download it and test it out rather than building whole MCP from the scratch. All right. Now, next two slide, I'm going to talk about the MCP connector and the gateway. So these slides are important in terms of if you are looking to build your own MCP connector and gateway, or you are looking for any third-party vendors, it's good to have some idea about what are the features that you need to have and what question you should ask to your vendors before you onboard those solutions. So MCP connector, again, is a bridge between MCP client and the backend MCP server. So I'll talk, the first point here is the authentication piece. This is one of the important features. So we use the OAuth 2.0 and proof key for code exchange framework that most of the banking application and some other high security applications are using it. So the way it works is, let's say you submit your prompt query. The connector will check your token. Do you have a valid token or not? If it is not, it will create a secret code for you. And it also creates some mathematical fingerprint for that given backend authorization server. So then once the authorization server send you a login request, you log in, you get the authorization code, and finally that authorization code get exchanged with a token that's going to save on your local machines. I know it sounds complicated, so I'm going to cover that in next slide, the whole flow. Next is session management. So we also, like moment you submit your query, we do create the unique session for that user and ensure that we maintain it and track it throughout the conversations. And this is very important to manage the sessions and build that communication between client and gateway. Now, third part is supportability to transport mode. We do support both STDIO, STTP, and SCC2. Again, like if you are trying to build like MCP server locally and you want to connect it, the MCP connector help you to connect to that local MCP through STDIO. And same thing is like going for the STTP as well. If you are hosting your MCP remotely, connector will also help you to connect to those servers as well. Now the gateway, again, like this is the authentication and routing hub. The way it works is, again, we already discussed how we embed this MCP connector, we install it locally, we embed that in MCP setting in your coding assistant tool. Now to connect to your backend MCP server, they has to go through the MCP gateway. And let's look at it, what are the features that we have in the gateway. So first is the request controller. So the moment you submit your prompt query, you know what, actually let's take an example. So imagine that you're trying to access the list of the repository from the Artifactory. So you submit your tool request saying that, hey, list repositories. So the moment that request comes, the request controller receive that request in a JSON format, right? It parse that, it remove the sensitive information and send it back to the Artifactory. Now, once the Artifactory respond back the response to this controller, the control will add a course header on top of it to making sure that that all the coding assistant or any third-party browser or agent who's trying to gateway, they should be secure enough to do it. So that's why the course header are very, very important feature to have. Second is auth handlers. Now continue with that example. Imagine like you have an Okta authentication in front of the Artifactory MCP servers. So the moment you submit your first tool request list repository, it go to the Artifactory, it take care of that login to the Artifactory, all those redirect URI stuff, and handling all the authorization code exchange, and trying to save that token back to your MCP connector and your local machine. Now the session management is the third part, like whatever the session which we generated through the connector, gateway is actually handle it. Gateway continue to maintain that session and ensure that the session remain active for certain hours to make sure that you continue to call and use the tools from the given MCP servers. Again, there is no session conflict here. We are making sure that all the other users who is also trying to use the same tool and server, there should not be any session conflict. Their session should be running simultaneously. Now, the request router. So this is like important too, like in terms of, imagine you have a gateway and you have thousands of MCP tool in there. So the moment you submit your list tool request, like list repository request, the request router understand that, hey, look, this is the tool I'm supposed to redirect to the Artifactory server, not to someone else, right? That smartness is there inside the router to take care of it. And then corporate proxy. I'm assuming that there are a lot of industries have their own core proxy behind any of their data sources. We do have our own too. So this gateway designed in a way that we enable those core proxy settings to make sure that we connect to those MCP server securely by following all our network policies and security protocol. Last but not least, the New Relic. Again, this gateway is designed in a way that it plug in any kind of logging information. So we added New Relic just to track that who is submitting the users, what tool you are requesting, and all those details. I have not added the RBAC yet because we are still working on it, just to ensure that, like before you making any tool request, you has to authorize through the RBAC rather than giving the whole list of tool access to you directly. So of course, like once you are authenticated, you will be allowed to connect to those backend MCP server. And if you are not, and if you are, let's say if your authentication configs are not exist in the auth handler, then your request will be going to be denied. All right, let's talk about how the auth flow will work. This is very important too, especially if your security team is trying to review it, how the overall things are working. So you can see on the top, like we have a developer who's trying to connect to the auth provider through a lot of this intermediate layer. So first, like developers will install that connector and enable that gateway endpoint in that MCP setting in their cursor. And they go ahead and request that tool request from there on. Then MCP connector asks for authorization URL from the gateway. Why? Because we already enabled the auth config inside the gateway for all MCP servers. Now the gateway going to return that auth URL, and then connector basically open that gateway URL, and gateway will take it further to the provider. Now the provider comes back in and ask you to log in. It will be a GitHub login, Google authentication, depends on like what kind of MCP server you are trying to connect with. Once you log in, and if your login is successful, then the auth provider send you the authorization code for it. So once you receive the authorization code, gateway redirect that browser URI to the client connector with that authorization code attached in it. And then finally, the connector is going to exchange the code with the gateway, and then gateway exchange that code further with provider. At this point of time, provider will understand that, hey, user is secure enough to accessing particular resources. So then it will go ahead and send that token back to connector that further going to save on your local machine, which generally we store in MCP token digestion file for certain hours. All right, these are some use cases we have. I know we have different stakeholders who has a different needs. So the first one is about for non-tech folks. If they want to connect to our remote enterprise MCP, they can just simply install that MCP connector, add that in their MCP setting config, and they can connect to our remote MCP through this gateway. Second is like for a little bit technical group, you want to use CLI all the time. So we have a tool I've installed for them, and they can connect to their local and remote via gateway. And then we have a specific set of group which is looking for virtual MCP solutions where you can combine multiple MCP together and do the tool virtualizations and add some custom optimization and parameters to it and let them connect also. So it's just like same solution, but it's a different nature compared to the one I just described here. Now, security risk and mitigations. Again, there are a lot of security risk involved in building such MCP. So I will highlight only few here. So first is like unverified endpoint. So we ensure that every base images and the packages we use on MCP, they are coming from internal registry, right? We are not downloading any packages from outside. And then token theft, which is very important point here. Like when you build your gateway, or you ask for that gateway solutions to your vendor, ask them, do they really save the token inside the gateway? We should never save the token there because it may be exposed that token to the LLMs or to your logging. So we just need to try to avoid that. And then third part is misconfiguration MCP. I saw like a lot of developers, like they're trying to ingest the secrets in terms of client ID or secrets or API keys through the environment variable inside the MCP, which is generally not recommended. Your MCP doesn't need to have the secret in it. All they need is like fetch that bearer token from authorizations from the auth login. That's all they need to connect to the backend MCP servers. And now the excessive scopes. Again, making sure that the moment you add your auth config, the one I showed in the MCP gateway slide, make sure that imagine that you are doing the Google authentication credential setup. All your scope has to be carefully reviewed. Don't try to open too many APIs to it. Second thing is every single tool has to be carefully reviewed, and if required, that has to be blocked as well through RBAC controls. And last, the injection and tool poisoning. Again, like the gateway should be smart enough to handle any PII input data, and also whatever the PII returns from your MCP servers. These are very important, and this has to be blocked to protect the data in general. All right, monitoring and compliance. Yeah, we do have New Relic. Just to add some of the monitoring stuff, we track like who is the user who's submitting those tools, what code you have been accepted, what code you have been rejected, have you got any authorization error. All those informations are being tracked on our dashboards, and we get a real-time alert on it. And these are beside our overall GKE health and monitoring on top of the gateway pods or MCP server pods. Now the compliance. So, there are a few things that we are also trying to address. So one thing is like how we can enable the two-level permissions and give that control to our security team to manage this SOC 2 compliance. And second is like how we can encrypt this sensitive token and contextual data at rest and in transit to avoid any unauthorized access. And then also PII reductions are very important in terms of model input and output, just to overall data safety. And then also we are trying to manage all the audit logs and automate some of the compliance reporting for overall governance and traceability. And last but not least, the data retention and deletion process to just ensuring adherence to some regulatory mandates. All right. This is next we have. We already built MCP Enterprise and local and virtual MCP for the various groups. Now our goal is to continue to support that MCP integration into upcoming AI agents. We already started building few, and we are also trying to add this into our analytics and ML workflows. We are also trying to unify the context to build the cross-domain intelligence. And third part is reduce the token waste from AI workflow. I know this feature is recently released by ToolHive, so we are looking forward to it and try to enable that in our system. And then last but not least, overall, simplify overall governance and security framework. That's all I have. Thank you for listening me. Again, if you have any questions, feel free to reach out to me over LinkedIn and also reach out to me on here lunch as well. Thank you.